We are going to start doing polynomial division. Today we're going to start with long division. And guys, just hold on with me. We have to do long division. I know you're probably like already PTSD. I don't want to do long division. But I promise on EOC, there's going to be one question where you have to do long division. We've got another method that we're going to do next that's going to be able to be used on most of our problems. But I guarantee there's going to be that one problem on a benchmark or EOC where we will have to use long division. So hang in with me. We got to see it. We got to do it. Okay. Your first blank here is division. Division allows us to find factors of polynomials and therefore the roots of the polynomials. So we're going to use division to find our factors, which will help us find the roots. Remember, those are going to be our solutions. Those are the zeros, the x-intercepts of our polynomial when it humps and bumps where it crosses the x-axis. So since we are talking about long division, let's throw it back with basic long division. What was it? What do we do? All the good things. So let's do some warm-up problems. Some of you are going to claim that you have never seen long division in your entire life. So let's look at some baby problems. Make sure that you are familiar with how to do long division before we dive into our polynomials. 731 divided by 3. Just some quick vocabulary. 731 is called your dividend, and 3 is going to be your divisor. So when you go and make your little division house, 3 is on the outside, 731 is on the inside. Okay. Now, you are going to start by looking only at the 7. You're going to ask yourself, okay, how many times will 3 go into 7? 2 times, because 2 times 3 is 6. And then you subtract. 7 minus 6 is 1. Okay, nothing more I can do there. So I bring down my next value. My next number is 3, making 13. And you do this process again. How many times will 3 go into 13? I know 3 times 4 is 12. So I'm going to write 12, subtract 13 minus 12 is 1. Bring down my last number, making 11. How many times will 3 go into 11? Well, 3 times 3 is 9. 11 minus 9 is 2. So we have remainder 2. Or what I want to kind of plant a seed for later, this would be 243 and 2/3. Took the 2 from my remainder, 3 from my divisor, made a fraction. And of course, your answer to a division problem is called a quotient. Okay, so all the good things. Let's do one more. 607 divided by 4. 4 is on the outside of the house. 607 is on the inside. How many times will 4 go into 6? 1 time. Writing 4 below, subtracting 6 minus 4 is 2. Bring down that 0. I've got 20. How many times will 4 go into 20? 5. 5 times. Nice and happy 20. Subtract and I get 0. Oh no, it's okay. Bring down another number. It's 7. How many times will 4 go into 7? 1 time. Subtract the 4, get a 3. Remainder 3. Or, planting seeds for later, 151 and 3/4 is my quotient. Yes? Okay. So that's long division, baby problems, back in the day elementary. Let's look at polynomial long division. You do have steps here. Let's walk through the steps as we look at number 1. Number 1 step number 1 says make sure the polynomial is written in descending order of degree. If any terms are missing, I am going to highlight that. If any terms are missing, use a 0 for the missing term. This will help with spacing. If there is a division problem on a benchmark or an EOC, I can just about guarantee for you, there's going to be a missing term. It's so rude. It's mean. The testing companies are awful, but you're going to have a missing term because students are going to forget to put in their 0. They're going to get a different answer. Okay. So I know I have one of those here. Watch out for that. Expect those. Expect there to be a missing term. So let's look at our polynomial number 1. It's x cubed x squared, x to the first, and then 6 is x to the 0. Okay, so I've got 3, 2, 1, 0. So all looks good there. There's where I'm looking. 3, 2, understood 1, and that's x to the 0. Yep. Number 2, determine what should be multiplied by the first term of the divisor. Okay, we're ready to set up our house. X plus 3 is on the outside of my house. X cubed plus 6x squared plus, this is a good place to check and make sure you have all of your terms in descending order. I would need, if it starts with x cubed, I need everything less than that. All right, step number 2, determine what should be multiplied by the first term of the divisor, the thing on the outside. The first term on this example is x, to equal the first term of the dividend. In this problem is x cubed. And write that at the top. Okay, so we're asking ourselves, what would we multiply x by to make it x cubed? That would be an x squared. X times x squared is x cubed. You see that? All right, step 3, multiply that answer, the x squared, by each term of your divisor, the thing on the outside, right? Earlier, let's look at the one in blue. When I got the 2, I did 2 times 3 is 6, and I wrote it to subtract it. That's what we're doing here. So I'm going to take x squared, and I'll multiply it by both of those numbers on the outside. X squared times x is x cubed, and the other one, do x squared times 3 is 3x squared. Now, number 4, super important, subtract carefully. All of this that I just came up with is being subtracted. I do recommend throw some parentheses on there, because look what's going to happen. I am going to subtract x cubed times x, or x cubed minus x cubed. But then I also need to do 6x squared minus 3x squared. Okay. Subtract carefully, and then we'll break down our next term. So x cubed minus x cubed is gone. Here's where I'm talking about. 6x squared minus 3x squared is 3x squared. You might even want to distribute your minus sign through to help make sure you don't forget that. All right, bring down your next term. Bring down the 11x and walk through those steps again. I'm going to use a different color. Let's say purple. And we're going to walk through those steps again. All right, repeat steps 2, 3, and 4 is what step number 5 says. So go back to step 2, determine what you're going to multiply x by to make it 3x squared. I would have to multiply by 3 and another x. 3x. Now, take 3x and multiply it by both terms on the outside. 3x times x is 3x squared. 3x times 3 is 9x. All of that is going to be subtracted. So careful, careful, careful. Maybe give yourself little subtraction signs through there and carefully subtract down. 3x squared minus 3x squared is gone. 11x minus 9x is 2x, and bring down your next term, our last term. So we have 2x plus 6. Walk through those steps again. We'll use green and show. We're going to look at the x in the dividend, or sorry, x in the divisor. What will we have to multiply x by to make it 2x? A 2. At the top, put plus 2 for your quotient. Then 2 times both the numbers in our divisor. So 2 times x is 2x. 2 times 3 is 6. Hey! All of that is getting subtracted away. 2x minus 2x is gone. 6 minus 6 is gone. 0. Your answer is x squared plus 3x plus 2. All of that from the top up there. And we did not have a remainder. It divided evenly. Cool? Let's do it again. Number 2. Set up my house. Number 2, x plus 1 is on the outside of the house. 2x squared plus 6x plus 7. Do I have all my terms? X squared, x to the first, and then my constant. I've got all my terms, not missing anything. Really, really keep your eyes peeled for that because it's going to happen. We're going to look at x and ask ourselves, what would we multiply x by to make it 2x squared? 2x. Now, multiply it. 2x times our divisor. 2x times x, 2x squared. 2x times 1 is 2x. Carefully subtract all the way through. The 2x squareds make 0. 6x minus 2x is 4x. Bring down your next term. All right, walk through the steps again. What would you multiply x by to get 4x? A 4. Okay, actually multiply 4 times your divisor. 4 times x is 4x. 4 times 1 is 4. Carefully subtract all the way across. 7 minus 4 is 3. Oh, so we have a remainder this time. Now, in class, to write our quotient, it will look like 2x plus 4 plus our remainder, 3, over our divisor. You're going to see some notation on Delta Math. I think it comes up on our next examples where it's asking for that. Write your quotient plus remainder over divisor. Okay, that's how all the benchmark questions are written as well. So this isn't an odd request from Delta Math. This is legit how you should write your answers. At the bottom of each of these problems, we have some statements, and I want to make sure to hit this home because this is very important concepts. On number 1, on the left side, at the bottom, it says, if the remainder after dividing is 0, which is what happened in number 1, we didn't have a remainder, it divided evenly, then the divisor is a factor. Hey, good news. Good news. Okay, so let me bring that home. If we did 12 divided by 3, it's 4. Okay, isn't 3 and 4 factors? 3 times 4 is 12, right? Divided evenly, they are factors. What if I divide 9 by 2? Yeah, like 4.5. I get a remainder, right? Because 2 and 4.5 are not factors. They don't divide evenly, and so they're not factors of 9. So we are going to use that principle to help us solve polynomials because now I know it's a factor. I can take a factor to help me find a root, a 0, and x-intercept. Yes? Now, on the other side, if there is a remainder, then the divisor is not a factor. This is a very important concept. I want to make sure that we are laying groundwork for that because this is how we're going to solve those polynomials. In number 2, we got a remainder. So even though it's super weird and crazy, 2x plus 4 is not a factor of, what was it? 2x squared plus 6x plus 7. 2x plus 4 was never multiplied with something else to give me 2x squared plus 6x plus 7. Okay? Was never a factor, was never multiplied with anything to get that original polynomial. Okay? We will come back to this. Let's go and look at your last 2 examples. Okay, I'm just going to go out on a limb and assume, since I put a giant bold statement of if there are terms that are missing, use a 0 placeholder, that maybe we're going to see those here on this example. Just going out on a limb. So let's check it out. It says x cubed minus 3x plus 2. It's divided by x minus 1. If there is a remainder, express the result in the form, here's what I was talking about, quotient plus remainder over divisor. Quotient, the Q makes sense, remainder R, that makes sense. I don't know why they chose B for divisor. I don't know. But we are going to divide those. All right, x minus 1 is on the outside of my house. X cubed minus 3x plus 2. Right? Oh, hold on. Scratch it back. make sure you have every term. So if it starts with x cubed, I also need an x squared. I don't have one. Put in a 0, then minus 3x, then plus 2. I need to represent every term. Or it's really clear here on the long division, like when I pull stuff down, it's not going to line up with like terms for me to add or subtract down. So you've got to put in this 0 placeholder. All right, ready to rock and roll. Look at x. What are you going to multiply x by to make it x cubed? X squared. Actually multiply x squared by your divisor. X squared times x, x cubed, x squared times -1, a negative x squared. See how now I can add, subtract like terms straight down? Yeah. X cubed minus x cubed is gone. 0 minus a negative, okay? So be super careful. You might want to go through and change your signs. Be super careful. This is going to give me a positive 1 x squared. Bring down my next term. What am I going to multiply x by to make it x squared? An x. X times x is x squared. X times -1, -1x. I'm going to carefully subtract it across. Let's see, this one's going to subtract. This one will add. Yikes. X squared minus x squared is gone. -3x plus 1x is -2x. Bring down the positive 2. What am I going to multiply x by to make it -2x? A -2. Multiply -2 with your divisor. That'll give me -2x. And -2 times a -1 is a +2. Hey, hey, hey. Awesome, awesome. Subtracting that is going to give me a 0 remainder. So my final answer, let me write it below. Final answer, x squared plus x minus 2. No remainder, therefore it is a factor. Planting seeds for later. It is a factor. So x squared plus x minus 2, our answer, our quotient. I can take that, and it was multiplied with x minus 1, which gave us that original polynomial. Let me add that. So at one point, x squared plus x minus 2 and x minus 1 multiplied together, and they gave us x cubed minus 3x plus 2. Division undoes multiplication, right? So what we just did was division. I undid multiplication. I found the original things that were multiplied together. Ha! Very helpful step for us later. Number 4, x plus 3 is on the outside of your house. I've got -3x cubed. I've got a cubed. I need a squared. Missing a squared. On your benchmarks, your EOCs, they're gonna give you a missing term. Just expect it. If I have a chance, if I remember, I will remind you before a benchmark or EOC. They're gonna skip a term. They will, because they're mean. They're rude. All right, set up in the house. What are you gonna multiply x by to make it -3x cubed? -3x squared. Multiply -3x squared with your divisor to get -3x cubed and -9x squared. All my terms are lining up nice and pretty because I put in that 0 placeholder. Carefully subtract. Notice my signs here are changing. So it's +9x squared. Bring down 26x. What are you going to multiply x by to make it 9x squared? 9x. Multiply 9x with our divisor to get 9x squared plus 27x, close, real close. Subtracting carefully, subtracting. 9x squareds cancel. 26x minus 27x is -1x. Bring down the 2. What are you going to multiply x by to make it -1x? Maybe a -1. -1x minus 3. Subtract ever so carefully. looks like x's canceled 2 plus 3 makes 5. Because we had a 2 minus the negative 3, so it's adding and gave us 5. So final answer, negative 3x squared plus 9x minus 1 plus remainder 5 over the divisor x plus 3. I know it's big and messy, but that's how you write your answer. The quotient piece on top of the house, the division house, your plus your remainder over divisor. This one is not a factor. Negative 3x squared plus 9x minus 1 is not a factor of our original problem. What was it? Negative 3x cubed plus 26x plus 2. There was never a time, never a moment in the entire world where negative 3x squared plus 9x minus 1 multiplied with something to give us negative 3x cubed plus 26x plus 2. Didn't happen. Nope. No good. So that's not going to be helpful for us solving later. Well, there you go, ladies and gentlemen. You just completed polynomial long division. Yes, you have to learn how to do long division. In fact, there's going to be some students that love long division. When I show you the other method next, you're going to be like, I'll just do long division. And I'm going to go, please don't. Because we're going to use polynomial division to solve polynomials up next. So you do need this skill, like I said, because there are scenarios where we have to do long division. I'll illustrate that more in the next lesson when we can use one method versus another. And then please, please, please remember in the back of your mind, they are going to be on your reviews and on your quizzes, the ones with missing terms. You've got to put in your 0 placeholder or you're going to mess up your entire problem. It's going to be a mess. And they are going to put those on benchmarks and EOCs, I can guarantee, because they're mean. They're mean. So try that, practice that. I'll see you in class, guys. Let me know if you have questions and have any issues. I'm glad to help.